Okay, we're going to learn how to do binomial expansion using Pascal's triangle today. So the first thing we have to know, what is a Pascal's triangle and how it works. So Pascal's triangle is where um, all these numbers that are at the end, they're all 1. Right? So all of these numbers are 1. And now I'm going to go up to certain rows, but they're all of these are 1. Also on the other side, these are also all 1s. So at the end, you're always going to have 1. All right, and I'm going to stop here. And then, so this is the first row, row 0. This is the second row. The third row is basically the addition of these two. So 1 plus 1 is 2. So this is going to be 2. This one up here, this one here is going to be the addition of these two. So 1 plus 2 is 3. And then 2 plus 1 is 3. That goes here. Same thing here. This one is going to be the addition of this. So 1 plus 3 is 4. And then 3 plus 3 is 6. 3 plus 1 is 4. Okay, same thing here. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And then I'm going to do one more. 1 plus 5 is 6. 10 plus 5 is 15. 10 plus 10 is 20. 10 plus 5 is 15. And then 5 plus 1 is 6. So these are actually, so if you look at the binomial expansion is basically you have some number plus or minus some other number to some power. Okay, that's what a binomial is. A binomial is when you add or subtract two terms. Okay, and then the power is where we're gonna expand using these exponents. So for row 0, this is gonna be the exponent. Row 2, these are gonna be the exponents. Row 3, 1, 2, 1. Sorry, row 2, 1, 2, 1. Row 3, 1, 3, 3, 1. So basically, whatever the power is, you're gonna have one more term. So x plus y to the first power is gonna have 2 terms. X plus y to the second power is gonna have 3 terms. Okay, but this is how you build Pascal's triangle. So all of these, the last, these are going to be ones here, and then the consecutive, these terms here are going to be the addition of the previous terms. Right, so let's do a couple of problems here. So 3x plus 2 to the third power. So we have the third row here. Okay, so we know that there are going to be 4 terms here. We already know the first thing is going to be is that there are going to be 4 terms here. All right, 4 terms, and I'm going to look at row 3. Okay, so it's going to be 1 3 3 1. Those are going to be the coefficients. So I can do 1 3 3 and 1. So the way it goes is that you're gonna have 1 and then you have 2 parentheses. Okay, then you're gonna have a plus sign and then the other coefficient 3, and then you're gonna have 2 parentheses again, and these parentheses are gonna be just the numbers that we have here, plus 3 and then 2 parentheses again, and then plus 1 and then 2 parentheses again. Running out of space here. Okay, so basically because it's the third power, I'm gonna have 4 terms, and this is the coefficients 1 3 3 1. So these are 1 3 3 1, and then I'm gonna do 2 parentheses each time. So these parentheses is going to be basically 3x here, and this is going to get the maximum power, which is the third. So 3x is going to be to the third power, and then the second one is going to be the 2 that starts with a 0 power. Okay, and then each time this is going to go 1 down and this is going to go 1 up after that. So all of these are same, so 3x and 2. So this is going to be 3x and it's going to be 2 here. 3x and 2. 3x and 2. Okay, so what happens here is that this is going to be 1 less. So this is going to be 2 now. This is going to go 1 up. If you look at the exponents, the sum has to be the same as this. So 3 plus 0, 2 plus 1 is same as 3. So 3 plus 0 is 3, 2 plus 1 is 3. Same thing here. 3, 2, so this is going to go 1, it's going to go 1 down, this is going to go 1 up. That's second power. And then this is going to be 0 power, and this is going to be 3 power, third power. Okay, and then you just simplify this. So the coefficient here is 1 times 3x to the third power. So 3 to the third power is 27. And then x to the third power is x cubed. Okay, anything to the power 0 is 1, so we don't have to write this. Just that's just 1 plus 3 here, and then 3 squared is 9, 9x squared, and then you have times 2 to the first power, so 9x squared here, and then times 2 to the first power is 2. Okay, plus you have 3 here, and then 3x to the first power is just 3x, and then you have times 2 squares. 2 squared is 4, so that's times 4, and then plus, again, this is 3x to the power 0. Anything to the power 0 is 1, so that's 1, that's 1, and then this is 2 to the third, so it's just 8, because these both are 1. 1 times 1 is 1. So let's clean this up a little bit here. So you got 1 times 27x cubed is 27x cubed. Okay, and then you have plus 9 times 3 is 27 times 2 is 54x squared. So that's 54x squared. Okay, plus 3 times 3 is 9. 9 times 4 is 36, 36x. And then plus 8. And that's the expansion of 3x plus 2 to the third power. This is again looking at this x cubed, x squared, x, and a constant. So it continuously goes down and it makes sense. Okay. All right, let's do one more that has a negative. So x minus 2y to the fourth power. So we know that this is going to have 5 terms. Okay, so we go to the row 4. So it's going to be this here, 1, 4, 6, 4, 1. Okay, 1, 4, 6, 4, 1. Right, so 1 and then 2 parentheses. Okay, plus 1, 4, and then 2 parentheses, plus 6, and then 2 parentheses, plus 1, 4, 6, 4 again, and then 2 parentheses plus 1, and then 2 parentheses. Okay, so 14641 right here. Those are my coefficients. They come from the Pascal's triangle, and then these are the two numbers that go here. So remember that I need to put the negative here, x and then negative 2y. For each one of them, you have x and negative 2y. And then the power, as we talked about earlier, it's going to be the same way. All right. So the x is going to get the highest power, which is the 4. Okay. And then this is going to get the 0 power. And then from there, and so 4 plus 0 is 4. So it has to add up to 4. Right, this is going to go 1 down. This is going to go 1 up. 3 plus 1 is 4. This is going to go 1 down again. This is going to go 1 up. 2 plus 2 is 4. It's going to go 1 down. 1. It's going to go 1 up. 3. It's going to go 1 down. 0. 1 up. 4. Okay, and so that's the setup. Once you got this, this should be good. Right, anything to the power 0, this is going to be 1. This is 1. So this is just, the first term is just x to the 4th. Okay, x to the 4th. Right, so here, you got a negative here. So whenever you have a negative here, it's going to be, the pattern is going to be plus, minus, plus, minus, plus, like that. Okay, so it's going to alternate the sign. Besides, when you multiply a positive and a negative here, you see what will happen here. So you have a 4 and you have a negative 2. This is the first power. So 4 times negative 2 is negative 8. Negative 8. And then you have x to the third power. And then you have the y to the first power. So that's just going to be the y. Okay, we have to look at the power here. If this was a second power, then this number will change. Right? Then let's look at this one here. Plus, you have a 6 here, and you have a negative 2 complete square. Again, this is a negative, but it's a second power, so it's going to become positive. So negative 2 squared is 4. 4 gets multiplied by 6, becomes 24. So this is 24. And then x squared. And then this becomes y squared. Okay, I'm not writing this negative 2 squared again because I already multiplied that by 6. Negative 2 complete squared is 4 times 6 is 24. Okay, so you see plus, minus, plus. I expect to see a minus sign here. That's going to happen because negative 2 to the third power is negative 2 times negative 2 times negative 2. That becomes negative 8. Gets multiplied by 4, becomes negative 32. Okay, and then you have x here, and then you have y to the third power. Okay, so as you see here, negative 2 to the third is negative 8, times 4 is negative 32, x, and then y cubed, and then plus, minus, so this is going to be a plus here. Right, x to the 0, that's going to be 1, okay? And this is 1, so 1 times 1 is 1. Negative 2 to the fourth power, negative 2 times negative 2 times negative 2 times negative 2, that's going to give me a positive 16. And then the y is to the fourth power. Okay, so basically that is all. That's the answer. Okay, x to the fourth, we've simplified everything. You see x cubed, x to the fourth, x cubed, x squared, x, and no x, and then no y, y squared, y cubed, y to the fourth. One is increasing, the other is decreasing. That is a pattern there. Okay, So that's your first page. Okay, so hopefully this makes sense. All right, so I'm going to go to the next page, and then this is the same thing. It says find the sixth term or find the third term. So I'm going to do this here actually. Find the third term in the expansion of y minus 4x to the third to the fourth power. So again, fourth power, so we're going to have 5 terms. So again, the coefficients are going to be 1, 4, 6, 4, 1. Okay, 1, 4, 6, 4, 1. And then we have to find the third term. So we know that the coefficient is going to be 6. Okay, so I'm just going to start that. I'm going to start with 6 because I need to find the third term. Third term is going to be, this is first, second, third. So it's going to know, I know that it's going to have 6 in the front. And then we know that this was going to be y to the fourth. This was going to be y to the fourth. So if I look at this, y to the fourth, y cubed, and y squared. So this is going to have to be y squared. Okay, and this is going to be, this was going to be negative 4x cubed, negative 4x cubed. This was going to be to the 0th power. This one would be the 1, and so this one have to be the second power, 0, 1, and 2. So negative 4x cubed, negative 4x cubed to the second power. Okay, so this is going to be the term. They are not asking you to expand the whole thing. They just want the third term. So that's why I'm not doing the whole problem. I'm just trying to save some work here. Okay, so 6y squared. I'm just going to work this here step by step. Okay, so times negative 4 squared. So I'm going to square the negative 4. Negative 4 complete square is becoming 16. And then x cubed squared is x to the 6th. Okay, now you multiply the numbers. Okay, multiply the numbers. So 6 times 16 is 96. 96. And then you have y squared. And you have x to the 6th. Okay, so the third term is this. All right, that is all. All right, so these are this page. This is how these examples go. I want to do a one-word problem, and then that'll be it. All right, so it says this one up here says Kyrie Irving makes 90% of his free throws. What is the likelihood that he will make 4 of his next 6 free throws? All right, so the probability, I'm just going to look at this as a probability kind of problem. So probability of making the free throw is 90%, so it's 0.9. That means that probability of not making a free throw would be 0.1 because this had to add up to 1 exactly. Okay, this is 0.9. So 10% would be he cannot make the free throw. That would be 0.1. So probability of making a free throw is 0.9. Probability of not making would be 0.1. So what is the likelihood that he will make 4 of the next 6 free throws? So what is the possibility? So he's trying for 6. 1, 2, 3, 4, 5, and 6. So what can happen is that he can make, I'm just going to say M for making. He can make the first 4. And does not make for the last 2. Okay, this is one probability. This is one possibility. Okay, so if we look at this, if he makes it each time, it's 0.9. So 0.9, he makes it 0.9, he makes it 0.9, he makes it 0.9, and then he doesn't make it. The probability of that is 0.1. So 0.1 and 0.1. So the total probability would be 0.9, 0.9, 0.9, 0.9. Multiply that, that would be 0.9 to the fourth. And the not making it would be 0.1 to the second power. Okay, so this is one possibility, but we know that this is not the only way. He can make and then not make and not make and then make, and there are many of them. So we need to find out, this is going to be happening every time, but what is the number? How many times this can happen? Right. So this comes from the coefficient. Right. This comes from the coefficient. So what we are doing here is that basically this is what we are doing. If we make it, okay, if we make it, it's basically going to be 0.9 m for making it, and then plus 0.1 for not making it, 0.1, and I'm going to say nm for not making it. And this is to the power sixth, because that's what, you know, he wants next 6 free throws. So all we have to find out is 0.9 is basically the fourth one. Okay, so what we need to do is we need to go to that table and find out where it does that happen. All right, so 0.9 to the fourth power. Okay, so if I go up here to the sixth row here, okay, let's see, so that's row 5 here, this would be row 6 here. So 0.9, okay, so 0.9, this would be to the sixth power, this would be to the fifth power, and this would be to the fourth power. So this is 15. This is the coefficient I'm looking for. All right, so it's 15 ways that that can happen. So all you do is just multiply that by 15. So 15 times 0.9 to the fourth times 0.1 squared. Okay, so all you're doing for this problem, guys, is that 0.9 plus 0.1 to the sixth power, m for making it, and m for not making it. And we know that this is 0.9 to the fourth and 0.1 to the second. So we look at the coefficient of that 0.9 to the fourth, and that's 15. And we just put that in the calculator and see what that is. So 15 times 0.9 to the fourth power, and then times 0.1 to the second power, and enter, and that will be the answer, 0.098. okay, 0.098. So 0.098, or you can say, if you want to convert that into percent, you just say that that's 9.8%. Just multiply that by 100. Okay, so let me make sure that that's, yep, 15 times 0.9 to the fourth power, and then 0.1 squared. Yep. Okay, so this is 9.8%. Okay, so this is it. You can finish this on your own, the rest of the problems, and then you have a quiz on Wednesday on this and some word problems. All right, see you.